طيب بسم الله الرحمن الرحيم. We'll talk today about the fundamental theorem of calculus, this section. Actually, I will split it into three parts. One part about these two fundamental theorem of calculus, which is mainly what? Just that the derivative and the integration are inverse of each other. So the integral of the derivative will give you the function, and the derivative of the integral will give you the function. So I will explain it, and then we'll do some exercises. And then the second part, which is about, by the way, it has this part, which is the first one, fundamental theorem of calculus, has a lot of questions because this is a very important thing. And then we'll talk about this net change theorem, which is just we'll apply that the integral of the derivative, which is the same thing, but we'll try to link it with calculating the total distance and the total displacement. If I want the distance and if I want the displacement, just I will find the integral of the velocity. But for the total distance, I need to find the integral of the absolute value of the velocity. And we'll do some problems about that. And we'll link it with the indefinite integral also. And then the last things, which about the average value, which is just roughly 1 over b, the average value of integrable function over a closed interval it will be closed interval ab, it will be 1 over b minus a integral of f of x from a to b, and also the mean value theorem, which means that the f average is equal to f at a value at a specific c. There exists a c in this interval, so that f average is equal f at that c. Okay, so let me start with the first one. As I said, it will be a lot of questions, but I think it's very important because from the name, it's fundamental theorem of calculus. It's like important theorem in calculus. What's the idea? If you have a function continuous in a closed interval and there is a capital F antiderivative, so the integral of capital F is an antiderivative, means f prime equal f of x. The integral of a to b f of x is the integral a to b f prime dx. So the derivative of the integral will give me the function f of x from a to b. So it will be capital F of b minus capital F of a. So this is the way to find the integral, the definite integral. Instead of doing it through the areas and such things and the Riemann sum, now we can do it quickly. And for example, if you want to do 1 to 3 x cubed dx, what's the antiderivative of x to the x cubed? I know the antiderivative, if f of x equal x cubed, antiderivative will be x to the power 4 over 4. So the answer is x to the power 4 over 4 from 1 to 3. Then just substitute. So that will be 3 to the power 4 over 4 minus 1 over 4. Just do the calculation. That will be 81 over 4 minus 1 over 4. That will be 20. Like what they did there. So no need the C, huh? The C we don't need it because it will be cancelled. So no need for the C. So I have capital F of A, F of B minus F of A. Just the formulas, just if you remember these formulas. And x to the power n, if n not equal to minus 1, what will be the antiderivative? It will be this one. This is ln absolute value. Don't forget the absolute value. B to the power x, b to the power x over ln b, cosine and sine, all of these functions, we know them. The antiderivative things, which is we did in Math 101. Yeah, so no need now to do these Riemann sum or right, left endpoints, the limit. No, we'll do it with the antiderivative. So this one, what will be the antiderivative of this one? Antiderivative is x cubed over 3 minus 3x. So this one will be x cubed over 3 minus 3x. Substitute from 1 to 2. Substitute the 2, that will be 8 over 3 minus 6 minus 1 over 3 minus 3. So what is my answer? My answer is my answer will be what? 7 over 3 minus 6 plus 3 minus 3. So that give me this 6 over 3 minus, 7 over 3 minus 3. This is 9 over 3, so it will be minus 2 over 3. Okay. Yeah. Same thing. What is this? This is 1 to 4. 1 to 4, 3x to the power half dx. I know how to find that derivative. I add 1 and multiply by its reciprocal. 2 over 3, x to the power 3 over 2. From 1 to 4. That give me what? 2x to the power 3 over 2 from 1 to 4. Substitute 2, 4, the square root of 4 is 2 cube, so 2 times 8 minus 2 times 1. So it will be 16 minus 2, which is 14. Okay. This one, what is the antiderivative for secant square? That is roughly tan x. So it will be tan x from 0 to pi over 4, which is 1 minus 0, which is 1. Tan pi over 4 is 1, and tan 0 is 0. Okay, if I have an absolute value, be careful. I need first to get rid of the absolute value. So if I substitute a value between 0 to 2, sometimes it's positive, sometimes it's negative. If you notice, this one, when it's positive, what is the one which will make it, will change the sign at half? So I have from 0 to 2. So from 0 to half, it will be negative. And from half to 2, it will be positive. So this one, integral, I will split it in 2 parts, from 0 to half. Let me do it in details. From half to 2. Okay, this one, negative, with 0 to half. This one, positive. So it means this is the integral of this. Minus 2x minus 1 dx, which is 1 minus 2x, if you want, instead of doing it this way. 1 minus 2x dx, plus the integral from half to 2 as is, 2x minus 1 dx. What will be that? That will be x minus x squared from 0 to half, plus x squared minus x from half to 2. Substitute. You have half minus 1 over 4. This is 0, 0. Okay, plus. Now this is 4 minus 2 minus 1 over 4 minus half. Okay, let me do it. This is 1 over 4. This is 2 minus 1 over 4 minus half is minus 1 over 4. So it will be plus 1 over 4. So the answer is, this will be what? A 2. Wait a minute. It will be x squared minus x is from half to 2. So plus 2, so that will be what? 5 over 2. Yeah, you can check the calculations. Find the area of the region. We know that. How to find the area between this to this? The area will be this. From 1 to E, the area has a different integral. From 1 to E, this is positive, huh? 1 over x. We know it's positive between 1 to E. So that will be 1 over x dx. So that give me what? Ln absolute value of x from 1 to a. Just apply the, so I have ln e minus ln 1. That will be 1. Okay. Let me do more problems. This one, easy one. That will be what? A to the power x from 1 to 3, which is a cubed minus a. The area under the parabola, I know this is positive, huh? So no need to, between 0 to 1, it's always positive. So it will be integral from 0 to 1, x squared dx, which I know that the derivative, x cubed over 3 from 0 to 1. So the answer is 1 over 3. Yeah, this easy problem, but just to be sure that we get it. This will be ln absolute value of x from 3 to 6. So that will be ln 6 minus ln 3, which is, I can write it ln 6 over 3. That will be ln 2. Okay. I know cosine is positive in this interval between 0 and pi over 2. So the area will be integral from 0 to pi over 2, from 0 to b. Huh? I want to find the area from 0 to b, where b is a value, any value between 0 to pi over 2. From 0 to b, it means the cosine is always positive of cosine x dx. What's the antiderivative of cosine? It will be sine x from 0 to b. So that'll give me what? Sine b minus sine 0. Sine 0 is 0. So that will be sine b. Yeah, these are easy ones. Just to be sure we understand, just antiderivative. We're doing nothing. So just to remind you about some formulas for the antiderivative. The only things new, it's about the absolute value. You need to split it before you do. You need to get rid of the absolute value, so you need to split it based on the interval. Yeah. Now the second fundamental theorem of calculus. Sometimes they call this is the first, this is second. I mean, both are okay. So the derivative of the integral, it will give you the function. Be careful. Yeah, we need the function to be continuous so we can integrate it. If it's continuous and if v of x is differentiable, this one is. Now, if I have the argument, notice here I have f of t, huh? I do not make f of x because this is up to x, huh? So I need to make it f of t. Now, if the argument is not x, it's function of x, then what will be the derivative of this integral? It will be f at that function times its derivative. Now, if I have the limit going from function of x to function of x, the derivative will be what? F of v, the derivative of v minus f of u, derivative of u. And notice I have a to x. I don't have x to a. Huh? So if it is x to a, what you will do, take minus sign, make it a to x. Now we can differentiate. We'll see some problems related to that. This is the second fundamental theorem of calculus. Let us do it quickly. What's the derivative of this? Just we'll do apply. A, I don't care what is A, huh? A as any number. So what is this? J prime will be square root 1 plus x squared. That's it. Derivative of a to the power x, 0 to the power x, f of t dt, just f of x. So just what I did, I find f, this is my f of a, f of t. So I find f of x. Let me write it in details. So this will be f of x, which is square root 1 plus x squared. That's it. Now, if I have it to not to x, to a function of x, like this one. So what will be the derivative? It will be f at that function times the derivative of f, times the derivative of that function. So I have, this is f of t. So this one will be f at x to the power 4 times x to the power 4 prime. What is f at x to the power 4? That will be secant. That will be secant. Yeah. That will be secant x to the power 4. What's the derivative of this? 4x cubed. Okay, so that give me 4x cubed secant x to the power. That's the answer. Okay. Now, this is f of t. I think it's the same. Yeah. So this is square root x squared plus 1. You can do it quickly. A, I don't care, just a value, huh? So that will be what? Cosine x cubed times derivative of x cubed, which is 3x squared cosine x cubed. Okay? Cosine x cubed. This one, direct, I have, this is a function, this is a function of x, this is a function of x. So I need to apply this theorem. Function to function. So f of the upper limit, f at that function in the upper limit times its derivative, minus f in the lower limit times its derivative with the minus sign, okay? So it will be, this is f of t. It will be f of x cubed times x cubed prime minus f of 3x times 3x prime. Okay, let me do the details. That give me what? X cubed plus 1 to the power 10 times 3x squared minus, this one will be what? 3x cubed plus 1 to the power 10 times 3. So that will give me 3x squared, x to the power 9 plus 1, x to the power 9 plus 1 all to the power 10 minus 3 times what? 27 x cubed plus 1 to the power 10. Okay, like in all of the old exams. Yeah. Now we need to, I have f of 1 and f prime at 1. F of 1 will be what? Integral 1 to 1 tan inverse t t. 1 to 1, that integral is what? 0. Now f prime, I need to find f prime at x. I need to do the same thing. So that will be tan inverse x cubed, derivative x cubed, 3x squared, minus tan inverse x squared times 2x. So what I want f prime at 1. It will be tan inverse of 1 times 3 minus tan inverse of 1 times 2. So I have 3 pi over 4 minus 2 pi over 4, which is give me pi over 4. So this is pi over 4 plus 0. So the answer is pi over 4. The answer is pi over 4. Sorry, this is my answer. That should be the answer. Not pi over 2. Yeah. Okay, so these are just to review fundamental theorem if it's continuous. If I have g of x equal this, its derivative will be f of x. The integral, this is f prime, where f is f prime. So the integral of f prime give me capital F of, the integral of capital F prime will be capital F of b minus f of a. So they are inverse of each other. I think this explains it clearly. This is the same as that one, okay? And this one, the same as this one, second one. Yeah. Now, this idea can be linked also to other things. For example, L'Hopital's rule. What is the limit? Look at these questions, where they link L'Hopital's rule with these fundamental theorem of calculus. Now, if you remember L'Hopital's rule, if I substitute, what you will get? 2 to 2, which is 0 over 0. So I can apply L'Hopital's rule to find the limit. So that will be the limit. T goes 3 derivative of this. Yeah, also to be careful. If f of he's doing it in terms of t. So f of t is equal to this. Yeah. How to find f prime? To find f prime, first I need to do what? Look, the formulas also, it has another trick. The formulas, all of these formulas, they have a to x. All the formulas we have before, always 0 to x, pi over 2 to x, 1 to x, 1. I have function the value to the function. So I need to make it this way. No. So what I will do, this one, I can make it minus integral 2 to t minus 1 ln x dx. So now it's ready. I can differentiate now. I have limit t goes to 3. It will be what? Minus ln t minus 1. Derivative of t minus 1 is 1. So nothing to worry about. Over, what's the derivative of this? 2. Can I substitute now? Yes. It will be minus ln 2 over 2. And that's the answer. Minus ln 2 over 2. So you combine Limited rule. Also this idea where I need to take a minus sign because I want it from the value to the function. Okay. But I did it here. Okay. Now the same thing, another way of writing it. Yeah, you can do it this way or the other way. Okay. So this is now the fundamental theorem of calculus. What will happen? What will be this? So this is like the antiderivative. The second one. This is like the antiderivative. So the answer is ln x, the integral will kill the derivative. I have ln x, square root of x from 1 to 4. Okay. And that give me what? Ln 4 over 2 minus ln 1, which is 0 over 1, so minus 1. So the answer is, what is this? This is half ln 4, which is ln 4 to the power half, which is ln 2. So the answer is ln 2. This is the answer. Okay. Yeah, this is again the same thing. Don't forget this. If I have from function to function, I need this. So just a summary of what we did in this part. Okay. Now, what he wants us to find the derivative. Find the derivative. خلاص. We'll do it. Okay. So it will be this is from x to 0, not from the value to x. So my first step, I take a minus sign, 0 to x, square root 1 plus secant t dt. What will be capital F prime now? It will be minus square root 1 plus secant x. Okay. That's it. Minus 1 plus, okay. Second problem. This one, just a hint here. Huh? Yeah. It's just a hint. I need to be sure about the minus sign. And this is what we did. This one, the same idea. First, I need to get rid of the minus sign. So that will be minus pi over 4, the square root of x, theta t theta, tan theta d theta. What will be y prime? Well, it will be minus. Now be careful. This is square root of x tan the square root of x times derivative of this, which is 1 over 2 square root of x. So what I am getting? Minus half tan square root of x. minus half tan square root of x. Find the derivative of the following functions. The same idea. This is sine. So first I need to get rid of the minus sign. So that will be minus 1 to sine x square root 1 plus tan square dt. Now that implies in the y prime will be what? Minus, by the way, this is the answer, minus square root 1 plus sine square x, derivative of sine, which is cosine x. So that's it. This one, I have function to function. So it will be capital F prime. Let me do it here. Capital F prime. It will be arctan to x times the derivative of this, which is 2, minus arctan square root of x, derivative of this, 1 over 2 root x. Yeah, 1 over 2 root. That's it. Okay. Yeah, like what we did here. Minus 1 over root 2 arctan of square root plus 2 arctan to x. Okay. I want to find the derivative of this one. What will be? Yeah, the solution is here, so I will write it here. I try to squeeze it here. Y prime will be what? Ln 1 plus 2 sine x. Instead of v, I will write this function times its derivative, which is cosine minus ln 1 plus 2 cosine x times derivative of this, which is minus sine x. So the answer is sine x. This is minus times minus, we'll make it plus. Ln 1 plus 2 cosine x plus cosine x, ln 1 plus 2 sine x. Okay. This one, I want to find the derivative of this one. That will be what? I want to see if there's space. Yeah. Yeah, the answer is 0. Why? Because, yeah, let me see where is the answer. The answer is here. So why is this? Because y prime will be what? This is a to x, so I have x square over x square plus 4 minus the same thing here. So I have x square over x square plus 4, which is 0. I need to deal with the space. Let's write it here. Y prime x square over x square plus 4 minus x square over x square plus 4, which is 0. And now differentiate this. It's function cubed, huh? Function cubed. This is the answer. So I'll try to squeeze it here. Y prime will be what? Function cubed 3, the function square, function cubed, huh? 3 times the function square times derivative of the function. Now derivative of this, which is, now I will do the fundamental theorem of calculus, that x cubed plus 1 to the power 10. Look at this, it's the same as this one. Okay. Now I want to find the derivative of this one. This is the answer. Okay. So I'll try to squeeze it here. What will be y prime? Y prime will be, I will substitute this 1 over square root 1 minus sine square times derivative of sine, which is cosine. And that is what? 1 over square root. I have the interval where the cosine is positive. So that will be 1 over square root of cosine square, cosine x. This is the absolute value of cosine x, which is cosine. Since cosine is positive, so the answer is 1. That give me cosine over cosine. Since absolute value of cosine is cosine, because this is the first and fourth quadrant. Find the linearization of this. Find the linearization, huh? Remember linearization? Linearization is what? L of x equal f of a, which is, this is my a, plus f of minus 1, f plus f prime at a, x minus a. This is the formula. By the way, this is the answer. This is the formula. Okay. G, huh? The function is G. So it's G of A, G prime of A, and this is A. This is A, and this is G. What will be G at A? G at A, very easy. It will be 3 plus, what is A minus 1? 1 to 1. Secant t minus 1 dt. 1 to 1. What's the integral of 1 to 1? That will be 0. That will be 3. Okay. What is G prime of X? Derivative of 3, 0. Now I will use fundamental theorem of calculus here. That give me secant x squared minus 1 times 2x. Times 2x. What will be G prime at minus 1? Okay. That will be secant 0, which is 1, times minus 2. So G prime will be minus 2. So it will be L of x. Oops. L of x will be G at 1, G at A, which is 3, plus or minus 2, x minus minus 1, that is plus 1. So I have 3 minus 2x minus 1. That give me 1 minus 2x. That will be my L of x, which is this one, minus 2x plus 1, or 1 minus 2x. Just he link it with the relation when I have this formula, if you remember it from Math 101. Evaluate this integral. Now it's the second part of, or the other fundamental theorem of calculus, where I need to find what? I need to find the antiderivative. I need to find the antiderivative just to be sure of the spaces. Yeah. What is the antiderivative of this? Part 1, x to the power 4 over 4 minus x squared plus 3x. I need to find this from minus 2 to 2. Yeah, substitute. What you will get? 2 to the power 4, 16 over 4. That will be 4 minus 4 plus 6 minus 2. It will be the same thing. 4 minus 4 minus 6. So that will be 6 plus 6, which is 12. So the answer for this one, 12. Oops. That's 12, which is correct. Now let me do this one. X squared plus square root of x. And antiderivative things. X cubed over 3. X to the power half. This is x to the power half. Huh? You can think of it as x to the power half. So I add 1. It will be 3 over 2. Plus 2 over 3. X to the power 3 over 2. This is the antiderivative things. From 0 to 1. 0 ما عندك مشكلة. That will be 1 over 3 plus 2 over 3. 1 over 3 plus 2 over 3 minus 0, which is 1. So this is the answer, it's 1. Antiderivative things, huh? What will be this? This, you add 1, huh? Number 3. You add 1, okay? So that will be what? Minus 1 over 5. So that will be minus 5 x to the power minus 1 over 5 from 1 to 32. From 1 to 32. minus -5 times 1 minus 5. So that will be 5 minus 5 over 2, which is 5 over 2. And that is the answer, 5 over 2. Okay, this one, 1 plus cosine x. The answer is pi. Why? What's the derivative of this? That will be x plus sine x from 0 to pi. That give me what? Pi sine pi 0 minus 0 by 0 minus 0. So that will be pi. Antiderivative thing. Just to make a quick review about the antiderivative. Then we'll do all problems. This one, what is the antiderivative of secant square? That will be tan. So this is 4 tan t. What's the antiderivative? This is by t minus 2. So I add 1. It will be minus by t minus 1. From where to where? From minus pi over 3 to minus pi over 4. Yeah, I need to substitute carefully. Minus pi over 4, that give me minus 4. Okay. That give me minus 4. I have minus pi over 4. So that give me minus 4 over pi. Huh? If I substitute, this is minus pi over 4. Huh? That minus pi times minus 4 over pi, that give me plus 4. Minus. Now minus pi over 3. It will be minus 4. What is tan pi over 3? Which is tan 60. It will be square root of 3. Square root of 3 over 2 over half. Sine pi over 3 over. Okay. Minus, now the spherical of this, which means plus 3. Which is, yeah, plus 3. And the minus pi times 3 over minus pi. So it's plus 3. That give me what? This is 0. That give me 4 square root of 3 minus 3. Which is this one? Good. Yeah. I try to squeeze the things, huh? Between 0 to pi, cosine x. I think if there is a space here, there's no space. Yeah, this one will be a little bit complicated because cosine is not positive or negative in this interval. So I need to split it. So this one, I need to split it into 2 parts. So that, let me try to squeeze it here. 6 will be half, or let me do it here. I think I put a space here. Half cosine x plus, 0 to pi, half cosine x plus absolute value of cosine x. Yeah. Notice this is sometimes positive, sometimes negative. So I split this. I know the cosine. This is the graph of the cosine. So with 0 to pi over 2, it's positive. From pi over 2 to pi, it's negative. So I'll make it from 0 to pi over 2. I split this integral first into 2 parts. Let me leave it with the absolute value. Plus the second part from pi over 2 to pi. Well, now I can control the absolute value. Now this one is minus cosine x. No, this is plus. This one is minus cosine x. So this is give me 0. خلاص. 0. Who cares? 0. That will be 0 to pi over 2. 2 cosine x, which is cosine x dx. Here I have 0. What is the integral of this? That will be sine x. From 0 to pi over 2. So that will be sine pi over 2 minus sine 0 which is 1. So the answer of this is 1. This one, easy one. This one is what? Integral x to the power 1 over 3. So I add 1, it will be 4 over 3. Let me try to write it here. That will be what? 3 over 4, x 4 over 3, from 1 to 8. And that give me what? Yeah, cube root of 8, 2 to the power 4. That will be 3 over 4 times 16 minus 3 over 4. So this is 4, this is 1. That will be 12 minus 3 over 4. 48 minus 3, that will be 45 over 4, which is this one. Okay. This one. I need to rewrite it first. Let me take it here. X minus 1 over square root of x. X minus 1 over square root of x from 1 to 9. This one, I can make it what? X, let me do it in details. Square root of x minus 1 over square root of x. Now x over x to the power half, that will be x to the power half minus x is minus half. Change it to power so I can do the calculation easily. Plus 1, that will be 2 over 3, x 3 over 2. Add 1, that will be minus 2, x to the power half. All of this from 1 to 9. Yeah, do the calculation. That will be 2 over 3. Cube root of 9, 3 cube times 27 minus 6. Okay. Minus, substitute at 1, 2 over 3 minus 2. Okay. What is the answer? 40 over 3. Yeah, to be sure I did the right calculation. This is 54 over 3 minus 6 plus 2 over 3 plus 2. So it will be 52 over 3 minus 4, which is 52 minus 12. That will be 40 over 3, which is the same answer. Let me do this one. Yeah, easy one. 0 to 2, y minus 1, 0 to 2, y minus 1, 2y plus 1 dy. Is it? Yeah. Just I will open the parentheses. I do the product. That give me 2y squared minus 2y plus y. That minus y minus 1. Now I do the derivative. That give me what? 2y cubed over 3 minus y squared over 2 minus y. From 0 to 2. 0 will be 0, no problem. That will be what? 2, 16 over 3 minus 2 minus 2 minus 0 خلاص. That will be 16 over 3 minus 4 will give me 4 over 3, which is this one. This one, yeah, let me try to do it here. That will be what? 1 to 2. I have 1 over v plus 3v squared dv. That give me what? Ln v plus v cubed. We want it from 1 to 2. That will give me ln 2 plus 8 minus ln 1, 0 minus 1. That give me ln 2 plus 7, which is this one. Now this one also is not that difficult. I can squeeze it here. 11, 1 to 18. That will be square root of 3. Z is minus half. dz. Square root of 3 is just a number. Add 1, that will be times 2. Z is half. From 1 to 18. Calculation. That will be 2 square root of 3. Square root of 18, which is 3 square root of 2. Yeah. 3 square root of 2, 1 minus 1 minus, that's the answer. This one, easy one, just you need to be careful about the calculation. What's the integral of x to the power e? It will be x to the power e plus 1 over e plus 1. What's the integral of e to the power x? It will be e to the power x. You want this from 0 to 1. At 1, you have what? 1 over e plus 1 plus e. 0, that will be 0 minus 1, which is this one. We did all of these ones. Okay, now we'll go to the old exams problems. This is mainly the idea that we say the main idea that the integral and the derivative, they are inverse of each other. That's the main idea. So we have two fundamental theorem of calculus. The derivative of the integral will give you the function. The integral of the derivative will give you the function. That's it. Let us do problems and see how. Okay. What they want? They want the double derivative. So I have f of u equal this. So that means f prime at u will be g at u. Okay, from this one. From this, I'm getting this. I want f double prime. That implies in f double prime of u will be g prime at u. G prime, I have g of u. So I can differentiate this. That will be what? This is the function. This is my v. So it will be square root tan u plus square root tan u multiplied by derivative of tan, which is secant square u. What they want? They want it at pi over 4. That will give me what? Square root tan pi over 4, which is 1, plus the square root of 1, which is 1, secant square pi over 4, which is 2. So that will be 2 square root of 2. That's it. You want f prime. Oh, be careful here. It's from x to 2. So first, I need to rewrite it minus 2 to x. T over then t dt. Now differentiate. F prime will be minus what? X over then x. That's it. Okay. If it's continuous, it's not this. Oh, he gave you a relation. And he want f at 0. What I will do, differentiate. Differentiate the left and the right hand side. Differentiate everything. If it's continuous, so everything is differential. I mean, integrable. No problem with the integration. Okay, so we have what? Here, if I do the fundamental theorem of calculus, differentiate, will give me what? This is f of x squared times 2x. Derivative of this, fundamental theorem of calculus, equal. Here I have product of two functions. So derivative of the first, e to x, plus the first derivative of the second, 2e to x. Plus, I will do integration, the fundamental theorem of calculus again. That will be what? It will be e minus x cubed, f of x cubed, minus e is minus x, f of x. Okay. What they want? They want f at 0. So to find f at 0, what I will do, I forget something here, sorry. This is the derivative of x cubed, I forget it. That will be 3x squared minus e minus x. Derivative of x, which is 1. So now substitute x equals 0. So I have what? F of 0, 0. That will be 1 in a minus 2 plus what? A 1 f of 0. This is 0. So plus this is 0. It's missing something here. F of x here. Yeah, because the function is e times f of t. So I have f of x here minus f of 0. So f of 0. Yeah. So I have take f of 0 to the others. So I have what? 0 equal minus 1 minus f of 0. So f of 0 will be minus 1, which is this. Just a matter of calculation. Huh? I have product rule here. Here I have product rule. Here I have fundamental theorem of calculus. Here I have fundamental theorem of calculus. And just substitute, you get it. Yeah, capital F prime, be careful here. This is 3 to 1, huh? 3 to 1. So let me do it the other way. So capital F of x, I will just rewrite it. Minus 1 to 3x et squared dt plus 1 to 3x ln t dt. Now I differentiate. F prime of x will be what? Minus e 3x squared, derivative of 3x, which is 3, plus ln 3x, don't forget, times 3. Now I need to find it at 1 over 3. That will be minus e 3 times 1 over 3, 1 squared, so it's 1 minus 3e. So that gives me minus 3e. Yeah. And now I have ln 1, huh? Which is 0. So I have minus 3, which is this one. Yeah. And I don't want to have a long video. I want to be sure how long is this video. Okay, I will stop. I think I will stop here, and then I will do another recording. Thank you.